Hello, guys. Today I will be talking about a quite controversial topic. It's called NoSQL. I hope you are ready to dive with me into this. NoSQL. Well, what is SQL? SQL is a standard structured query language that has been used to query our relational databases, and it was developed in the 1970s. The data is linked via relationships because of the columns, the primary keys, and this has been used as the backbone for many of our modern applications. And it's easy to query this type of data because you can link them when you're running your queries. These tables have been great to use. However, some of you know how long these queries take when you have complex joins or you're working with rather large data sets. Let me not talk about the amount of inner joins you end up using when you use these type of databases. The cost to run these databases is quite high because to scale it, you can vertically scale it by increasing computer memory, or you can increase the speed. However, it's difficult to distribute because you still need a centralized system that keeps hold of all the relationships. And if you were to scale it, you would have to replicate the read datasets. So you would have a main primary, which has all the data, and then you replicate it to the reads. However, the cost of running this in production with full big data is quite expensive. But fear not, this is not the only option available to developers now. There's a new database called NoSQL. These are schemaless databases that came up in the year around 2009 when developers wanted to distribute and evolve the data instead of being stuck to a schema. These databases are known as schemaless databases, meaning the structure of the data is not defined at the start, and it gives the developers much more freedom when developing. The type of databases you get with NoSQL are document databases, key value databases, graph databases where the relationships are very important, and wide column databases. So let me introduce you to one of my favorite NoSQL databases, MongoDB. This is a non-relational database which uses a document model to store the database. For agile development, this is unbeatable because your data is stored in a document that can evolve. So you can have a username, you can end up having email, a phone number, and you're not stuck on a set schema. The data is also stored in JSON format. JSON stands for JavaScript Object Notation, which is what is used on the internet mainly to interface between APIs. And everyone loves JSON, right? These databases are very easy to scale horizontally because they are made of a collection. A collection holds the whole database, but you can distribute it by sharding, which involves splitting and distributing the data into different shards. So each shard will have a quarter of the collection size. And if you need to query it, it will be localized to your area. But I want you guys to see how much hype there is around these type of databases. Let me tell you about Google Bigtable. When Google was starting to grow and they needed to store our personalized user data or our search history, they needed a database that could grow with them and also meet the requirements for low latency responses because they handle millions of requests per second. So they used an equivalent of a document model called Google Bigtable. When Amazon had to migrate its data because they were outgrowing the relational database that was crashing when they had Black Fridays or Amazon Days, Prime Days, they created their own DynamoDB and published a paper where they spoke about where they can handle these type of requests and multiple types of data. Another one is Azure Cosmos DB. This one is used mainly for Internet of Things. And if you want to know the scale of the growth of these non-relational databases, the MongoDB that I mentioned is set to make $1 billion in revenue in the fiscal year 2023. These databases are very good to be used with big data like Internet of Things. Toyota Material Handling Europe migrated its data because they have over 100,000 forklifts that are connected and send billions of requests per day, and they needed a low latency database. The Forbes website also migrated its data to a non-relational database so that it could be able to make use of the flexibility which comes with these databases by storing different kinds of rich media in a page. A document would then store what is displayed on the news article that you're reading. It can either be videos, text, and it is all beautifully stored in the schemaless database. So this type of database seems too good to be true, right? It is in a way because there's something called the CAP theorem. The CAP theorem stands for consistency, availability, and partial tolerance. It means that you need to make a trade away whether you're going to focus on being always available, handling millions of requests, and the data is not always consistent, or being consistent and not handling so much, but you know that the data is very consistent. So when you're still dealing with systems like purchases or banking, you need your relational database because the data needs to be consistent and the same everywhere. But then when you have evolving big data sets and you have content management systems, you can use something like a non-relational database because the data grows with you. And also another factor that might hamper people to transfer to these non-relational database is teaching the team to not use SQL to querying, which takes some time. So in the end, when a client comes to you and needs a database for a project, think about what you need and your pros and cons. Do not just stick to SQL because that is all you've been taught. Think about if you need high flexibility, schemaless, and a lot of big data that is growing, then go for the NoSQL. But if you still need your acidity, use relational databases and choose wisely because you are not only limited to SQL, you can use different types of databases. Thank you.